In this lecture, we want to discuss the theory behind the multilinear regression. Multilinear regression tries to find relation between two or more independent variables xi and one dependent variable y. In simple linear regression, x is a single variable, but here we have a two or more x. In this type of regression, we have a data set as follows. We have only one response variable y and p vector based x, xi to xip. Multilinear regression model assumes that the relationship between the dependent variable y and the p-vector of regressors xi is linear as follows. We can write y as a linear equation based on input variable x, and we can define a vector equation as follows: x transpose multiplied by beta plus epsilon. Often these n equations are stacked together and written in vector form as a y equal x multiplied by beta plus epsilon. And y, x, and beta are vectors as follows. X is a regressor or independent variables. Y is a regressant or dependent variable. Beta is a regression coefficient. We want to find beta. We must find betas to create multilinear regression model. We can use OLS here again, but all parameters are vector. You can find beta from OLS method. The beta formula can be written as follows. We must find beta from this equation, but multilinear regression do it for us, and Python code do it for us, and it is very good. After creating a regression model, we can estimate y. But as you know, any method never tells us exact value of y and only predict it, so we called it y hat. Every estimation method has an error, and we don't have a method with 100% accuracy. So to calculate accuracy, we need some metrics as follows: coefficient of determination, or R squared, and mean squared error, or MSE. First, we discuss about R squared. In statistics, the coefficient of determination denoted R2 or small r2 and pronounced R squared is the proportion of the variance in the dependent variable that is predictable from the independent variables. The most general definition of the coefficient of determination is equal to this equation: R squared equal to y minus SS residual divided by SS total. This parameter defined as follows: SS total is equal to sigma yi minus y average. Y average equals to sigma yi divided by n, and we calculate this parameter and we must power it to the 2. So next we must find SS residual. SS residual is equal difference between predicted value and real value, and defined as follows. And you can name it sigma EI to the power of 2. After find these two parameters, you can define r squared as follows. And r squared equal to is our desired, and we want to build such a method with this r squared. Of course, in theory, and as you know, we must have a 100% accuracy to have r squared equal to 1. Next, we discuss about mean squared error. In statistics, the mean squared error MSE or mean squared deviation MSD of an estimator measures the average of the squares of the error or deviations as follows. MSE equal 1 divided by n sigma y hat minus y, and this sigma calculate difference between predicted value of y and real value of y, and square them to find the mean square error. So n equals to the number of output data, y hat is a predicted value of y, and y is the actual value. Again, our desired is MSE equals to 0, and we want to find y hat equal to yi in theory, of course, and when we have a 100% accuracy, we can have a MSE equal to 0. So to see the practical version of these equations, let's code and make some program to test our theory and see our result. So stay tuned to the next lecture.